Thank you, Andy. It's great to be here and hopefully give you an insight into my world of Formula One and the role that AWS are playing. I like to think of Formula One as a gladiatorial sport between the drivers and a virtual war between the engineers and technicians to produce the best car. And it's a contest, it's a complete team contest. Neither can win without the other. We're the fastest racing cars on the planet, 230 miles an hour. But what's really impressive is we pull 5G in cornering and braking. It's a big business and a big sport, and it's growing. We race in 21 different countries, and we have more than 500 million fans. And we're generating multi-dollar revenues for both the teams and our business. It's about going fast in every part of the competition, but the races aren't only won out on the track. A fast pit stop can lose or win a race, and every millisecond counts. So take a look at this, but look carefully or you might miss it. So 1.6 seconds to change 4 wheels and tires. And you can imagine the training that goes into that, and that's just typical of Formula One. It's also a contest of innovative minds, the virtual war that I mentioned. And every team has hundreds of engineers, all trying to produce the best car, the best aerodynamics, the best chassis, the best engine. And undoubtedly, standing still is going backwards in Formula One. And to my mind, these are the most technologically advanced racing cars in the world. After 3 decades of working in teams, I joined Formula One Motorsport in 2016 with a mission. Make sure we had even better racing cars, make sure we had the best action on the track, and develop ways that our fans can engage with the sport like never before. We're the most data-rich sport in the world, and data fuels our performance. Each car has more than 120 sensors producing thousands of streams of data, and more than 1 million data points per second are transmitted between the car and the pits during a race. We chose AWS to be our partner to help unlock all of this data for the benefit of the lifeblood of our sport, the fans. We've focused on 2 initiatives so far, using high-performance computing to develop better and more raceable cars, and to use machine learning to increase fan engagement. And I'd like to take a closer look. Formula One helps to develop the rules and regulations of the sport. And we now have put a team together specifically to do that task. Amazingly, it had never been done before. And currently, the cars suffer badly when they're following each other. The airflow from the car in front disturbs the car behind too much. And we want to make the aerodynamics of the cars more benign and much less sensitive to encourage wheel-to-wheel action. So we're developing designs using 2 cars, one following another, and we're doing it mainly through CFD. And as you can imagine, this is a massively complex problem and has never been done before. AWS high-performance computing is enabling us to do this and experiment faster and better than ever before. We also want to give our fans a better insight into what's happening on the track. And using Amazon SageMaker, we can build models that help us understand how a car is being driven. Is the driver attacking, or is he in conservation mode? So we're training machine learning models using this huge amount of data that we have in Formula One. And we're using those models to make predictions of what's going to happen in the race. We call these F1 Insights. And for the 2018 season, we've started the process. We're digging deeper to show you where the performance is coming from. When is a car faster? Why is it faster? And I'm about to show you an example from Mexico in a recent race. And on the screen, you'll see a graphic that compares two drivers, Ricciardo and Hartley. Take a look. Look at the graphic on the lower right side, and you can compare Ricciardo's corner speed as he follows Hartley. And this comparison helps the fans see where and how Ricciardo is gaining time. And it's not always on the straights. We're not stopping there. And for next season, we're expanding F1 Insights for our viewers. By further integrating the telemetry data, such as the car position, the tire condition, even the weather, we can use SageMaker to predict car performance, pit stops, and race strategy. I'm going to give you a world-first preview of some prospective and exciting new AI integrations into next year's F1 TV broadcast. And I've selected 3 new cases to give you an insight. Look at the box on the right. We know that somebody's in trouble. His rear tires are overheating. But we can look at the history of the tires and how they've worked and where he is in the race. And machine learning can help us apply a proper analysis of a situation. And we can bring that information to the fans and help them understand whether the guy's in trouble or whether he can manage the situation. And these are insights the team's always had, but we're going to bring them out to the fans and show them what's happening. Here's another fascinating element for our fans, overtaking. Wheel-to-wheel racing is the essence and critical aspect of the sport. And now with machine learning and using live data and historical data, we can make predictions about what's going to happen. So the graphic on the right shows what we expect is going to happen in this event. Now, what's great about this is that the teams don't have all this data. We as Formula One know the data from both cars, and we can make this comparison. And that's never been done before. The pit stop. It's the major strategic element of the race, and one stop is mandatory. Stopping at the right time, fitting the right tire, can win or lose the race. And we're going to take all the data and give the fans an insight into why they stopped and when they stopped. Did the team and driver make the right call? So the info box you see on the bottom is giving the fans that insight that we can build using machine learning. Further down the road, what's really exciting is we're going to investigate the influence of the tracks and the racing formats on the quality of the racing. Can we create tracks that achieve better racing and better overtaking? Can we build models to allow us to do that? Can we change the format of racing to make it more exciting and less predictable? For instance, what happens if we change the formation of the starting grid? So instead of being spread out, it's bunched up. And we believe that using machine learning, AWS is enabling us to do these things. I hope I've been able to give you an F1 insight into the work we're doing. I'm incredibly excited about this new phase, and the partnership with AWS is bringing so many opportunities, and I hope you'll be able to get an insight into what we're doing. Thank you for your time.